Let us solve this particular question now. This question says that it is required to design a helical compression spring subjected to a maximum force of 1250 Newton. So let me just write the given conditions that we have. A maximum force of 1250 Newton is given to us. The deflection of the spring corresponding to the maximum force should be approximately 30 mm. It means the deflection is also given to us. That is, when we are applying a maximum force of 1250 Newton, the corresponding maximum deflection is approximately 30 mm. So this is the deflection which is given to us, but it is not exact deflection. This is approx deflection. Approximate deflection is this. After that, it says the spring index can be taken as 6. So capital C is 6. The spring is made of patented and cold drawn steel wire. The ultimate tensile strength and modulus of rigidity of the spring materials are 1090 and 81370 Newton per mm square. So ultimate tensile strength is given to us. It means SUT is given to us, which is 1090 Newton per mm square. Also, modulus of rigidity is G given to us, which is 81370. And after that, permissible shear stress for the spring wire should be taken as 50% of the ultimate tensile strength. It means permissible shear stress for the spring wire should be taken as 50% of SUT, which means tau will be equal to 0.5 into SUT. Okay, so the value of tau will be, that is half of this 1090. So it will be 545 Newton per mm square. Now calculate. First is the spring wire diameter, that is a coil diameter. So small d निकालना है आपको. Mean coil diameter, that is capital D, and number of active coils, that is capital N. Total number of coils, that is NT. Free length of the spring, and pitch of the coil. So there are 6 terms which we need to find out in this question. So one by one we will calculate all these terms. So let us start with first, that is wire diameter. Now, in order to find out the wire diameter, I explained you that we will use load stress equation. So according to load stress equation, okay, the formula is, that is tau will be equal to K, that is Wahl's factor, into 8PC divided by pi d square. Okay, directly we are using the formula which we have spring index, because the spring index given to us. So it will be tau is equal to K into 8PC divided by pi d square. Let us say this is equation number 1. Now in this formula, you know, we have tau, we have P, C, we have, and we need to find out D. But K we also have to find out, because we do not have K right now. So Wahl's factor, as we know, the formula for Wahl's factor is, that is capital K will be equal to 4C minus 1 divided by 4C minus 4 plus 0.615 divided by C. This is the formula for finding out the Wahl's factor. So in this question, spring index is already given to us, which is 6. And when you will put the value of 6 in this particular formula, you will get the value of K. So just let me just write the formula. Let me just write the magnitude, that what will be the magnitude for K. It will be 1.2525. Okay, so this is the value of K that we have. Now from 1, We have tau as 555. Okay, 1.2525 8 into P. P is 1250 into C spring index 6 divided by pi d square. So in this particular question now, there is only one unknown, which is d. So from here you will easily calculate your d, that is t इस तरफ ले आइए d square and इस term को इस तरफ ले आइए और उसका under root ले लीजिए. You will get the value of d. I'm writing the value, that is 6.63 and approximately equal to, let us say it is 7 mm. So this is the first point which we need to find out. ये हमसे पूछा गया था कि स्प्रिंग का डायमीटर कितना होना चाहिए, कॉइल डायमीटर कितना होना चाहिए, इट इज 7 mm. So first, now let us let us find out the mean coil diameter. Mean coil diameter, that is capital D. Now as we know, we have the formula for spring index as the ratio of the mean coil diameter to the wire diameter. So from here we will find out easily capital D as C into D, and it will be equal to 6 into 6 is the spring index and D is the wire diameter, so it will be 42 mm. So see how the things are now very easy for us in order to find out the values. So mean coil diameter भी आ गया हमारे पास. Now number of active coils. Number of active coils. And we know the notation for active coil is N. N is the number of active coil. Now, I explained you while I was explaining that how to design a helical compression spring, that load stress equation is used in order to find out the wire diameter and the mean coil diameter. But in order to find out the active number of coils or total number of coils, we have to use load deflection equations, because there are two types of equations which we generally use in order to design the springs. So now we will use load deflection equation here, and according to load deflection equation, you know that delta will be equal to 8p d cube and divided by gd4. Okay, this is the formula in order to find out the number of active coils, where you know that delta is the deflection and P is the force and G is the modulus of rigidity, small d is the wire diameter. So from here now you will find out your N, that is N from here will be equal to, that is delta into G d4 divided by 8p d cube. Okay, so now all the values are we have all the values. Delta is given, G is given, small d हमने निकाल दिया है. So now directly I'm just writing that what value will be there for N, that is 7.91. 7.91, or you can say N is approximately equal to 8 coils. So there are 8 coils which are active. Active number of coils means when we are applying a force, 8 coils are contributing to the spring action. Okay, 8 coils are contributing to the spring action, means they are deflecting when we are applying a force of 1250. Okay, now total number of coils. Let us move ahead and let us solve fourth part, that is total number of coils. And total number of coils will be NT, and we know total number of coils will be active coils plus inactive coils. But in order to find out the inactive coils, we must know what is the end of the spring, means the springs are square and grounded ends, or there are 4 types of ends as I explained you, and out of these 4 it must be given to us that what are the ends of the springs. Since in this question it is not given that what is the end of the spring, so you will have to assume this. So you can write a line over here that we are assuming that spring has square and grounded ends. And for square and grounded ends, let me just explain you one thing. This one, ये टेबल था हमारे पास, देखिए. अब if you are assuming a square ends, okay, we are assuming that we have a square and ground ends. It means I'm assuming this particular thing. So active number of coils from here will be nt minus 2. Okay, from this particular from this particular table, you are getting the value of active number of turns as nt minus 2, where 2 are the inactive coils. Okay, so n will be equal to nt minus 2, and from here now we will find out total number of coils as n plus 2. So as we know that n is 8 plus 2, so total number of coils are 10. So in our spring there are total 10 number of coils, and out of those 10 number of coils, 2 coils are inactive, and inactive coils are those coils which are not contributing to the spring action, means they are not getting deflected when we are applying the force. I hope it is clear. Okay, and after that we have to find out the fifth thing is free length. Okay, free length. Now as we know that free length will be equal to free length, the formula for free length I explained already, that it is compressed length plus deflection. Compressed length plus deflection, and we can further write this as, that is solid length plus total axial gap plus total axial gap plus deflection, and this deflection will be actual deflection, not approximate. Remember this thing. Deflection should be actual. So now from this equation, let us say it is equation number 2, we will find out the free length. Now what is solid length? Solid length, as we know, that is, this is nt into d. Total number of coils we already find out, 10, into spring wire diameter is how much? It was let me just check, 7. Okay, so 7, so it is coming out 70 mm. After that your total axial gap, so total axial gap now from here will be nt minus 1 into gap between adjacent coils. This is the formula for total axial gap. From here we know 10 number of total coils are there, minus 1, and let us assume that we are assuming a gap between the adjacent coil is 1 mm. Okay, so it is coming out your 9 mm. Total axial gap that we are getting is 9 mm, and actual deflection, how you will calculate your actual deflection? So actual deflection now you will find out from load deflection equation as 8 PD cube n upon GD4. So put all the values, that is, now you can put the value of n as 8 coils, and P and D are given to us, all the terms are given to us. So when you will put all the values, you will get the actual deflection as 30.34. So this is the actual deflection which you will use here. ठीक है ना, हमारे पास जो given था that was approximate, but हमने actual निकाल दिया. Actual is coming 30.34. तो हमने सब चीजें निकाल दी. Now from equation number 2. Now from equation number 2, your free length is, solid length is 70 plus total axial gap between the adjacent Total axial gap will be 9 mm plus 30.34. And when you will solve this, it is coming out 109.34 and approximately equal to 110 mm. So this is the answer. I hope it is clear that how we will find out free length. Okay. And at last, we need to find out pitch of the coil. Okay. P. And as we know that pitch of the spring is free length divided by total number of coils minus 1. This was the formula. Now free length is, we have 110 अभी निकाला हमने ऊपर, divided by 10 minus 1, and when you will solve this it will 12.15 mm. So ये हमने spring को डिजाइन कर दिया. This is how you will design your spring. Designing of springs means that you are calculating each and every dimension of the spring, depending upon the given conditions that we have, how much force is applied on the spring and what is the deflection in the spring after applying the force. उसके बाद फिर हमें जब स्प्रिंग को डिजाइन करना है तो हमें उसका वायर डायमीटर, मीन कॉइल डायमीटर, उसका फ्री लेंथ, उसकी एक्टिव नंबर ऑफ कॉइल्स, इनएक्टिव नंबर ऑफ कॉइल्स, फ्री लेंथ, पिच ऑफ द स्प्रिंग, ये सब हमें निकालना पड़ेगा. सो वी हैव डिजाइंड आवर स्प्रिंग और लास्ट में हमसे ये पूछा गया था कि ड्रॉ अ नीट स्केच ऑफ द स्प्रिंग शोइंग इट्स वेरियस डायमेंशंस. ओके, पेपर में तो देखो आपको बनाने की जरूरत है नहीं, पूछा नहीं जाता है, बट अभी इस क्वेश्चन में पूछा हुआ है तो यू नो लेट मी जस्ट शो यू दैट इस तरह से आप स्प्रिंग को फिर बता सकते हो. बिकॉज ये फ्री लेंथ आ गया आपका, दिस इज द फ्री लेंथ, यू नो वेरी वेल 110 अभी निकाला हमने, ठीक है ना. दिस इज द मीन कॉइल डायमीटर कैपिटल डी 42 निकाला हमने. ये पिच निकाली अभी हमने स्मॉल पी, ठीक है ना, 12.15 mm. ये देखिए यहाँ पे 12.15 mm. ये 7 mm, दिस इज द वायर डायमीटर, स्मॉल डी आपके पास दे रखा है. और उसके बाद आउटसाइड डायमीटर हमारे पास 49, दिस इज द इनसाइड डायमीटर. ओके, ये सब चीजें हैं जो हमने निकाली. दिस इज बेसिकली योर स्प्रिंग, हाउ वी विल डिजाइन द स्प्रिंग. नाउ लेट अस मूव अहेड एंड solve one more question on this particular topic. This is example 10.2. So this question says a helical compression spring which is made of circular wire is subjected to an axial force which varies from 2.5 kilonewton to 3.5 kilonewton. Now in this question the force is varying. Okay, the force is varying from 2500 newton to 3500 newton. Okay, and over this range of force the deflection of the spring should be approximately 5 mm. इस range के लिए ये कह रहा है कि deflection of the spring should be approximately 5 mm. Once again, deflection is given to us, but it is approximate, not exact. Now the spring index can be taken as 5. The spring has square and ground ends. देखिए, now in this question there is no need to assume the ends of the springs because it is given that it has square and ground ends. That is fourth condition. Spring is made of patented and cold drawn steel wire with ultimate tensile strength of 1050. Same, just like previous question, and G, modulus of rigidity is 8.370 Newton per mm square. Permissible stress, once again, permissible shear stress is 50% of ultimate tensile strength. Okay, rest conditions are same. Now we need to find out or design the spring and calculate wire diameter, mean coil diameter, number of active coils, total number of coils, solid length, यहाँ पे solid length पूछी हुई है, free length, required spring rate. Now what is spring rate? Spring rate is K, small k, capital K is your Hall factor. So spring rate, spring constant, rate of spring, all these terms are synonyms of the spring rate. So force per unit deflection, that is your spring rate को निकालना हमने. तो required and actual दोनों, ये मैं बताता हूँ आपको कैसे करना है. So let us try to solve this question. Write all the given conditions that we have. Okay, so force is given to us P, that is 2.5 kilonewton to 3.5 kilonewton. ये range दी हुई है. This is not minus sign. It's a range. So you can write that this P is given to us 2500 Newton to 3500 Newton. ठीक है ना, 2500 न्यूटन टू 3500 न्यूटन हमने कन्वर्ट कर दिया किलो न्यूटन को न्यूटन में. Over this range the deflection is 5 mm. Okay, so deflection delta 5 mm. Spring index is 5. यहाँ पे spring index 5 है, पिछले क्वेश्चन में 6 था. Spring has square and ground ends. ये given है हमारे पास, square and ground ends. Okay, SUT is given to us, ultimate tensile strength 1050 Newton per mm square. Modulus of rigidity is also given. And permissible shear stress is 50% of SUT. It is given. If it was not given, it is understandable that it is always 50% of ultimate tensile strength, and its value is coming 545 Newton per mm square. Okay, so now let us try to find out each and every values. The procedure will remain the same now. Just like we have solved the previous question, उसी तरह से करना है हमने. It means first आपको निकालना है wire diameter, and in order to find out the wire diameter we have to use load stress equation, and according to load stress equation now it will be tau k 8 pc upon pi d square, and k from here will be Wahl's factor. It will be 4c minus 1 divided by 4c minus 4 plus 0.615 divided by c. And जब इसमें आप c की वैल्यू 5 पुट करोगे, so you will get the value of k. और मैं डायरेक्ट लिख रहा हूँ कि value of k is coming how much? It is 1050. SUT is 1050 और पिछले वाले क्वेश्चन में क्या था? अच्छा 1090 था पिछले वाले क्वेश्चन में. ओके, इसमें 1050 है, so it is 525. Okay, it will be 525. So k यहाँ से आपके पास जो आएगा, that k is coming 1.3105. ठीक है, so now from 1 now from 1 you are getting as tau as 525 will be equal to k 1.31058 into p. See, p we are now calculating the wire diameter of the spring, so you need to take the value as maximum force, which is out of 2500 to 3500 Newton. So maximum force is 3500 Newton. So p यहाँ पे याद रखिए 3500 Newton रहना आपको, into c is 5 divided by pi d square. Now there is only one unknown, that is d. So from here your d will be 10.55, approximately equal to 11 mm. So this is the first answer. Second, mean coil diameter. So as you know, spring index is ratio of mean coil diameter to the wire diameter. From here it will be C into D. So C, as we have 5 spring index, D is 11 mm. So it is coming out 55 mm. So this is second. Now third, number of active coils. देखिए, if you know the fundamentals how to solve the questions, then the questions will become very easy for us. Number of active coils n, and we know we will use load deflection equation for this, and load deflection equation will be delta will be equal to 8 PdQ n upon GD4. So all the values we have here. But remember one thing, delta is how much? Delta is approximate. That is when we are applying a force and that force is varying from 2500 to 3500 Newton, means force maximum से minimum vary कर रही है, तो उसमें फिर एक्टिव नंबर ऑफ कॉइल्स आपको निकालनी है. सो इन दिस केस अब आपको जो पी पुट करना है बेसिकली वो रेंज लेनी है आपको. ओके, नाउ फ्रॉम हेयर जब आप सॉल्व करोगे इसको इस पर्टिकुलर इक्वेशन को, डेल्टा तो आपको लेना है यहाँ पे how much we have 5 mm is equal to 8 into P. P now you will have to take 3500 minus 2500 because it's a range into D cube. So that is 55 cube into N निकालना है आपको यहाँ से, divided by 81370 into wire diameter की power 4, that is 11. बस ये चीज ध्यान रखना आपने, यहाँ पे there is only one unknown which is n, and from here your n is coming how much? 4.48, approximately equal to 5 number of coils. So there are total 5 coils which are active. तो ये हमारे पास आ गया आंसर 5 coils. Okay, next बात करते हैं total number of coils. So this is your fourth part, I guess. Total number of coils. So total number of coils will be based on square and ground ends. And as we know, based upon square and ground ends that we have on the condition that we have of square and ground ends, we know n is equal to nt minus 2, and from here nt will be equal to n plus 2. So 5 coils were there, so 5 plus 2, 7 are total number of coils. So this is the answer. And next we need to find out the solid length. We know solid length as total number of coils multiplied by wire diameter will be the solid length. And solid length क्या होती है? When we are applying a force on a spring in such a way that the one coil is touching the another coil, or all the adjacent coils are touching each other, and further compression is not possible after that. That is called as your solid length. You are measuring the length of the spring along the axis of the spring when the spring coils are touching each other. That is called as your solid length. And total number of coils are 7 multiplied by wire diameter, that is 11. So after that you can say that 77 mm is the solid length. And next we have free length. Okay, next we have to find out free length. So now free length, as directly I'm writing the formula, that is solid length plus total axial gap plus deflection actual. सॉलिड लेंथ मैंने निकाल दिया, टोटल एक्सियल गैप निकाल लेते हैं यहाँ से, इसको इक्वेशन नंबर 2 बोल दीजिए. टोटल एक्सियल गैप total axial gap will be equal to nt minus 1 into gap between adjacent coils. ठीक है, so it will be your total axial gap. So 7 minus 1 into gap between adjacent coils. So in this question, 0.5 mm of gap is considered between the adjacent coils. You can assume in the range up to 2 mm. Okay, 0.5 mm, 1 mm, 1.5 mm, or 2 mm. It depends upon us. So in textbook, it is given as 0.5 mm. So I'm taking as 0.5 mm. So after solving this, you are getting 3 mm. Okay, because 7 minus 1, 6, 6 का half कितना होगा 3 mm. Now let us find out the actual deflection. Actual deflection निकालने के लिए देखिए, अब हमारे पास आपको पता ही है कि deflection जो given है वो approximate है 5 mm. Let us find out actual deflection. Actual deflection find out करने के लिए you have the formula 8 PD cube n upon GD 4. So in order to find out the actual deflection, कि कितना deflection, actual maximum deflection की बात कर रहा हूँ मैं. So आपको क्या करना पड़ेगा इसमें 8 into maximum force लेना पड़ेगा यहाँ पे भी. That is 3500 into D, capital D आपने निकाल दिया है. How much is this 55 cube into active number of coils are 5 divided by G into wire diameter 11. So when you will solve this, you will get your actual deflection as 30. Wait, when you will solve this, you are getting your actual deflection as 19.55. So see, 5 mm given था मैं, but actual deflection is coming out 19.54. Now put all these values in equation number 2 and you will get the value of free length. Therefore, from 2, free length now will be equal to, will be solid length as 77 mm plus total axial gap as 3 mm plus 19.55. When you will solve this, you will get your answer as 19.55 mm approximately. Let's just say it is 100 mm. Okay, so this is the free length. I hope it is clear. One second. Okay, now let us find out seventh term as required spring rate. So in order to find out the required spring rate K, we know we have the formula force per unit deflection. Okay, and force is varying from 3500 to 3500 to 2500. So यहाँ पे आपको लेना पड़ेगा required spring rate में कितना required spring rate आना चाहिए. 3500 minus 2500 divided by deflection, that is 5 mm deflection. Approximate बोला था ना कि when the force is varying from 3500 to 2500 or 2500 to 3500, the approximate deflection is 5. तो इस क्वेश्चन का यूज करते हुए आपको required spring rate मिलेगा and it is 200 Newton per mm. ठीक है ना. And the last that we have is actual spring rate. So in actual spring rate, what we will do, formula will remain the same. Small k will be equal to force per unit deflection, but deflection हमें क्या लेना पड़ेगा यहाँ पे, actual deflection जो हमारे पास आया था ना, या आप भी बोल सकते हो deflection will be 8 PD cube n upon GD4. And from here your K will be P divided by 8 PD cube N into, इसको आप ऊपर ले आइए, GD4. We have all the values, put all the values and you will get the value of K. So K from here, it will be coming 179.01 Newton per mm. ठीक है ना? So this is how we will solve the numerical problems on design of springs, helical springs. I hope this is clear to you.